you show with the cover or without the cover?
Yes.
The surface area? So the one with the cover is more stable, or without the cover is more stable because it doesn't have use? There's more surface. You just go.
Okay, so the question was about the this one here.
Yes.
Okay, when I take the total number of ribs that are in here by the total length and the fact that they're 3 inches, so like if I do all of the math, it comes up that the grand total of all the surface area, that when the wind is blowing at this, there are 745 square feet of surface area that the wind can get a hold of. Now, when I take, so when the structure is finished, like the way they've got the framing here in the back, and so they're going to get that covered, the whole surface area of that end is only roughly 540 square feet. So, and then you've got, like you can see the wind braces that are on here. Okay, so not only do you have a smaller area that's exposed to the weather, but because it's all tied together, so collectively there's actually a lot less stress on the building when the cover is on than before. Another thing that has come up with one of my customers, that for years they put all their buildings up with no wind braces. They had a situation where they had lots of greenhouses, so eventually it starts adding up, but their philosophy was when the cover is on and everything is square, nothing can move, because basically you have to rip that cover before something will shift. So not only do you have less surface area when you have the roof on, but you've got all this extra material stiffening it and bracing it. Answer the question?
So it's stronger.
Stronger, definitely stronger. Another,
plastic.
yes. What? Yeah. One comment that I get quite often is when people are putting a building up and they see a building like this, and they'll come along the side like they want to test it to see how strong this is. And a lot of the strength of this is in the jiggle, like there's a little bit of springiness to the steel. That contributes to the strength. And they get kind of concerned, you know, like, is this thing as strong as what has been sold to me? I say, put the cover on, and then we'll talk again. And there's not a single person that's ever complained to me about this perception of an inferior building has ever commented negatively again once the cover is on. So even plastic, it really stiffens the building. Yes?
Could you explain maybe how we could analyze the distance for our trees for a good wind break? It's like, could you go into a little more detail? The first thing that needs to be taken into account is sort of the urgency of it. Is if you have, like if you're in a really brutally windy spot, then you know there really is an importance to have an effective windbreak sooner than later. In that particular situation, what you're going to wind up doing is planting 2 rows, like something that is very fast growing, even though it might be shorter lived, and planting something that is going to be a more effective windbreak down the road. There is no like mathematical formula that I know of that will say, okay, you know, like a Norway spruce spaced this far apart, this many years will give you this much. I'm sure that somebody has calculated.
I'm pretty sure Ministry of Agriculture publication on windbreaks, they charted out with the height of the windbreak and then the decrease of wind speed, measuring out distance from. There is that information. I've seen it in pamphlets from the Ministry of Agriculture on windbreaks.
Well, it doesn't surprise me that that the information is available, and certainly if I was in a situation you know, where I needed to know that information. It's so easy to Google almost anything these days that you ask the question and I'm sure you're going to come up with the answer. Another thing to keep in mind with a windbreak, though, is the potential shadowing that you're going to get. Because if you're going to be getting significant shadowing on the structure at certain times of the day, that will definitely decrease your growing capacity. So you need to be far enough away and think of the future.
Can you comment on whether the building is upwind of a windbreak versus downwind of a windbreak?
Okay,
there might be a situation where you really need or want the building ends up being upwind of a barrier to the wind, like a windbreak.
Okay, the question, for any that you didn't hear, it had to be on whether the structure is upwind of the windbreak or downwind. Like certainly the preferred placement of it is going to be downwind from the windbreak, so that you're in that area where you've got the decreased wind speed, and that whole area is then more sheltered. If it's the other way around, you potentially are in an area where you could actually be making the situation worse, because the wind is being deflected, and especially if you have really tall trees, you know, the wind is going to be deflected up again and is going to create some extra funny swirling of the wind. Yes?
Yeah, have you ever used chains and turnbuckles to square a building as opposed to rigid bracing?
Yes. Okay, so the question has to do with chains and turnbuckles for squaring rather than bracing. Wind bracing, there's two different kinds of bracing for a building, and it depends on whether the load is a compression load or a tensile load. Compression meaning that it gets squished, tensile means that it's being pulled. The reason that cross ties are very effective for a snow load is because you're being pulled. So like it can't stretch that steel. But when it's a wind coming from the side, it potentially can, the brace can jiggle up and down. So when you are doing the diagonal bracing, when the bracing comes up like this, it's considered as a compression load. So like you're bracing up like this for something that's being pushed against. And it is effective, but with certain limitations. When you have your cables with turnbuckles going the other way, that's a tensile thing. So it is important that everything is tied together properly this way, because the load that is coming at the back side is actually being held back by the cables that are coming from the other side. So back and forth like that. So that again is a variation that I do discuss with the engineer when we're putting different braces on. Cables are easier to get to in more spots than the typical wind braces. So in some of the evaluations, and when we get into this where we're close to a problem, like just sort of across the line of the load, one of the ways that we can just beef it up a little bit is to switch from traditional wind braces to cables. Yes?
Do you have any experience with this place foundation?
In regards to?
As a foundation for
I have, okay, so the question has to do with formed foundation walls. You have all of the same sort of questions that apply when you're doing that, because you have to make sure that the foundation is stable in its own right, because in most cases, the wall itself is going to be of enough weight that the structure on it is almost of no consideration. So it's important to have like a proper footing under it so that that wall is stable. If that thing isn't stable on its own, the little bit of extra force, you know, comparatively speaking, that's going to be put on it is really of no consequence. Now, it's not something that I have a lot of experience with, for the simple reason that it's extremely expensive relative to what's needed for these buildings. Yes?
All these greenhouses that you show pictures for, are they all engineered, or is there a greenhouse design that is covered by the entire building code? That I don't have to go and get an engineer to engineer it and put his stamp and pay money on it.
Yeah.
I can build a house any size I want, as long as I use certain techniques that are covered in the building code. Don't have to pay an engineer to engineer, right?
Okay, with all the different greenhouses that we have, like as I showed in one of the slides of what we submit to the engineer for evaluation, so that the building will be assessed for the particular conditions in that area, and you know, the engineer puts his stamp on it. That means that when you take that drawing to the building official, now you should be good to go for that particular area. The problem that we run into with this whole idea, there is a huge area of interpretation on the rules on these things. Basically because this is foreign territory to a lot of the building officials. So I go through the whole gamut of, you don't need a permit for this, to you're not putting this kind of thing up in this township. I had one really bizarre example where two individuals, they bought identical buildings, they were neighbors, and well, to get a better price, they bought together and the same thing. And the one was allowed to put it up and the other one wasn't, even though it was identical buildings in the same municipality. And that was because the one was being used as a greenhouse and the other one was being used as storage. So there were different rules that applied, even though it was identical building, to a greenhouse than there was to a storage building. And that's why very often when I get an order from something, the customer will specify, make sure that the bill says, you know, says this or it says that, because, you know, the rules are less. And unfortunately, like as these buildings get more prevalent, and you know, not to put a knock on young people, you're getting, you know, somebody that's in that capacity that has been book trained and doesn't have a lot of this background, you know, real world experience that they know what will work, and so they start applying the letter of the law, and we're getting into some really bizarre requirements. Yes?
The specific recommendations for rainfall drainage? Is it
Pardon me?
for rainfall drainage on either side of the structure? Because it seems to me like, you know, good drainage and good holding power could be somewhat mutually exclusive.
Well, see, okay, so the question was regarding the drainage and the holding power around the sides of the building. When you get all of that extra rain coming in that particular area, now if the ground is sufficiently compacted, then with the excess rain you're getting runoff, and so it's going to run away from there, and it's not going to jeopardize the integrity of the holding power where that foundation is. Where the problem is if that water that's coming off there
doesn't have anywhere to go. And so now that ground is going to become more saturated. So if you're in a situation where the water doesn't have anywhere to go, you need to give it somewhere to go through that drainage system. And depending on how close or far apart the structures are, you can have a common tile drain in between, you know, where you put crushed gravel on and stuff, so that again you're tapering the soil, you're creating that flow going to that spot where the water can go, so that it can be gotten rid of, and so then you're not running into the risk of that area turning to mush. And again, if it turns to mush, that by itself is not going to cause a problem. But if you get the wrong kind of wind coming at this and creating this uplift, and you don't have the holding power, that's when you could get the situation like with the one where it showed where the thing turned upside down. Yes?
Just a comment to that too. Like a hillside adjacent to your structure, when you're in the freeze-thaw cycle, can also flood the inside if you don't have that drainage on the uphill side of the structure. It's happened to someone.
Yeah, so like one of the things that I had missed in covering when we were talking about the uneven structure loading, and which applies to the comment there. The structures are made so that, you know, they're peaked like that so they will shed snow. So if you have a structure that's being built up a hillside, not only does the snow slide faster off of one side than off of the other side, you also, the water that is coming up, the snow, the water that's coming off on this side is going to be inclined to come back this way, which is inside the building. But having that uneven snow loading where it slides off of one side and onto the other side, you're going to get that sideways push. So it is important to have the building on a flat surface from side to side. Any other questions? Yes?
Do you ever build these structures and collect the water rather than let it drain away?
Yes. And so the question has to do with collecting of the water, and particularly in areas where you know, well water is not very easily accessible. What we've done quite often is supply an oversized cover that would allow to make a little bit of a trough on the side, so that the water, instead of the water just coming like this and dispersing around, it's going to go to the end where it can be collected. Now, and so that would be a potential consideration too when we're talking about like installing proper drainage so that you're protecting that area. If installing a proper drain isn't a possibility, one of the ways of dealing that would simply be, you know, make a little bit of a trough on either side so that you can shed the water off the end or collect it. Any other questions? Once again, I thank you for your attention.